Hello everyone. My name is Akanksha Agarwala and this is Team 2 Deliverable's sixth presentation on our project called Squander. For our agenda today, we will be going over our team member details, then we will be discussing about our project overview and personas. Then we will be discussing about the technologies that we use, followed by the design architecture and the sprint recap. Then we will be going over our product backlog, followed by spring backlog. Then we will be discussing about the retrospective and the future sprint. Then we will be demonstrating our project, ending with our conclusion. As you all know, my team is formed of five amazing and talented individuals. On our cloud engineer is Austin Blaze, who has contributed to the architecture of the project by integrating different features and services and by creating it as an infrastructure as a code, followed by our machine learning engineer, who is Nicholas Wong, who is responsible for designing the computer vision model architecture, where he's responsible for training and evaluating the model performance by gathering image data for training. Then is our iOS developer Rajat Nagafkar, who is responsible for designing and development of the Squander application, where he has integrated the computer vision model with the UI of the application, and he is also responsible for testing the application to provide a better user experience. Then is our full stack developer, Suryadeep Nalana, who has contributed to the design and development of the Squander application layout and prototype. He is also responsible for the technical paper documentation, and he is making sure by testing their application on a daily basis to make sure that it is a user friendly application. Then comes me, Akanksha Agarwala, who is a project manager and a scrum master. My responsibilities includes leading the team meetings and keeping the team on task. I also maintain our project's GitHub repository and Wiki page, and I also documented the test cases and helped Suryadeep go in the technical paper as well.
Project overview. Problem statement. With the vast population of people around the world, the amount of waste produced has been gradually increasing with the increase in population. On an average, the world produces 2 billion tons of urban solid waste yearly, and United States being the highest producers of waste among others. Around the world, the waste that is produced remains unprocessed due to lack of recycling knowledge with the people. Our scanner app overcomes this problem by producing a complete solution to organize and plan the disposal of waste through image recognition technology using machine learning algorithm to detect recyclable waste from images and produce proper disposable. With our app, we make people be responsible and contribute to make this world a better place. Project description. Our Squander application is an image-based waste detection mobile application. It is worked by a user submits an image to the application and a trained machine learning model runs on the image and gives results and information. The application is a simple tool to detect waste with best accuracy results and easy steps to undergo the process in the application. And one more thing, why you should use the application is it because it produces nearest recycling location along the rates and option to schedule a pickup personas. Zil, uh, Zil is a 32-year-old. He's an event organizer. Uh, he has organized many big parties. He takes all the responsibilities such as handling the decorations of the event and catering the food. His company particularly known for the food that is served to the people with tasty and hygienic food. After the party ends, the Food that is left should be trashed carefully, and Sill is responsible to it. Sill can do easily with Squander application by taking the image of this his trash and finding all the information of what kind of waste that can be trashed that is found within his image, and where he can take this trash to dump and schedule a pickup of his trash from nearest recycling factory location on the application. Simon. Simon is a mechanic. His age is of 35 years. He inspects the vehicles like cars, motorbicycle, light trucks that comes to his garage for a repair. His work produces a lot of metallic waste in a day that comes from repairing the vehicles, and his metallic waste can be taken by recycling companies, and Simon can make money out of it. He can contact the recycling company and have a deal using Squander app. David. David has retired from his sales executive job recently. After producing more than 30 years of his service, he was successful in his field and has been an inspiration for others. After the retirement, he wanted to get his house renovated. Now he is passing his time by involving in the construction work with something he can do. With Squander app, David can participate in cleaning the construction waste from his site that can be detect the waste material and find recycling company location to trash the waste, keeping the environmental at a better place. Minimal viable product. The features are map integration with nearby recycling factory location, scheduling the pickup of recycling waste by the factory, creation of user profile for each user uses the application, and showing history of a pickup that is scheduled by a user, and finally showing the recycling statistics for an each user.
Hi guys, so I'll be taking through the technologies that we used in the project. We didn't have much changes from the previous implementation, and we're only making modifications on the current technologies that we already have. Um, as then previously, we still have Python as our backend, which is used for all the integrations of the front end and also provides an API interface for connecting the front end with the backend. We also have Google Maps integrations to find the recycling locations. And to cover the machine learning models, we have TensorFlow and Keras. To power the infrastructure as a code, we have AWS Cloud Formation. The iOS development kit as Swift and Codeman allows us to provide users with easy access to machine learning models from their mobile devices, and Swift allows us to develop the front end that later connects or communicates with the backend. As for the architecture design, we still are maintaining the previous architecture, and the architecture is full-fledged. We would not be making any more changes to architecture, but we would be providing more changes to the machine learning models and the CI/CD. So, how the architecture is that the developer would be committing changes to GitHub, and these changes would trigger a CI/CD pipeline, and that would run the interface in the code in AWS pipeline. And these pipelines could trigger once all the tests and violation has been completed. These pipelines can trigger a deploy using AWS Cloud Permission. The Cloud Permission would deploy the whole infrastructure in AWS Cloud, including the identity providers and the machine learning models and other resources associated with the machine learning models like the Cloud One. And then we also provide um, different architecture, the front end of the application, that's the iOS mobile device, the mobile application. This is available for the users to be downloaded, and it has the capability to communicate with the backend. So the application itself has been coded in Swift and it uses an MVC architecture.
I will be talking about our machine learning algorithm. Our algorithm splits up the image into pixels and passes them into an input layer of nodes. Then the information gets passed through several hidden layers until we reach our output layer, which tells us what the picture was classified as with corresponding confidence values for each of the classes assigned. Next, to talk about model classification, the model is able to classify images into their 6 classes: cardboard, glass, metal, paper, plastic, and miscellaneous trash. On the right, you can see a few example images we used for the training process of this model. To evaluate our model, we look at the training and the validation accuracy of the model. The training accuracy is the accuracy we observe when training the model, and the validation accuracy is what we observe when we run a series of test images through the model again. Although the model validation accuracy is not quite up to standard, we can see from the example on the left that the model is able to identify objects correctly when the image is clear and devoid of obstructions. To fix this issue, we implement something called transfer learning. Transfer learning is the act of using a pre-trained model that is usually trained on a much larger data set, but is made to recognize something else, and we use that to leverage and add layers to our existing model to fine-tune the weights and the heuristic values in the model. This allows us to get a much better result without going through the hassle of finding more and more images and still not reaching nearly the training set size of the pre-trained model. Now to talk about our sprint overview. To give a recap of Sprint 5, we added some UI improvements with the navigation bar, and we added our team information to the page for the user to see. We also worked on model accuracy and allocated focus to deployment on AWS. Based on the burn down chart, we were a little slow to start, and then we picked up pace, but inevitably fell a little short. Perhaps next time in our next sprint, we'll look to split up the tasks into smaller ones. Now, to compare Sprint 5 and Sprint 6, as I said before, in Sprint 5, we looked at future goals and did the required research to achieve those goals. We also improved the model accuracy and added navigation bar to our application. In Sprint 6, we added recycle locations and the map view of those locations. We also added the functionality of loading relevant recycle locations after the image is scanned. From our committee's advice, we look to make several improvements to this presentation. The improvements we tried to make were updating the user stories and acceptance criteria into a better format. Our velocity chart we improved by adding the ratio and calculated average. For our MVP, we updated it to include all relevant points. We removed the project requirements slide. We reorganized the slides to match the checklist provided. And lastly, we updated the retrospective slide to more accurately perform a retrospective. To do this, we want to create a problem to solution workflow. Next, Austin will be talking about our backlog.
So the backlog for this sprint, we have the whole stories that we had on previously when we started off. And after sprint 5, we have not added to the backlog. So whatever we worked on sprint 6 was from the backlog, and thereby we have reduced the backlog. Um, so from the product backlog, we chose um, around 4 user stories and some enablers for the sprint backlog. Each of them has been provided with a key, and then it would have summary. And we also defined on what kind of priorities or how much work for the efforts we would have. And then we also have the status on the sprint backlog that we handled. And as you would see that we have Sprint SQD 65, where the Mark wants to have details of the working hours, which was having a high priority, but we still have that in progress. And the user stories and acceptance criteria that we worked in here are, from the Sprint backlog are these four. The rest of the enablers from the backlog has been completed. So what we have here is the user story and its acceptance criteria in the format that was standardized for the sprints. So SQ67 has John as an engineer. He was working on having to view multiple recycle locations so that he could choose to navigate to one that's most accessible to him. And the acceptance criteria was that when he uploads an image of the garbage and when he needs to find a recycle location, he will be presented with multiple locations if he have multiple locations and the density of the area that he's searching for. And the story SQD74 has a Simon um, requesting for a map view for him to plan his route more intuitively. So with Simon, we found that he has to do a lot of traveling between the projects that he works on, which happens to be in multiple locations. And now that allowing him to have a map view allows him to plan his route more intuitively. So when he uploads an image of the garbage or the recyclables, and when he needs to view multiple recycle locations, we provide him with a feature that allows him to view those locations in a map view. And they were allowing him to make intuitive decisions on what route he could take so that he could drop off the recycles. And with David, he's a retiree. He wanted to have a better experience with the app, and he decided that we decided that having allowing us to automatically load locations once he uploads an image would help him to reduce the number of interactions that he could have before the before his goal is achieved, which is to find the recycle locations. So we decided to uh, to automatically load the locations for him. And for XU75, we have Mark. He has a homeowner. He was valuing more communications with the services and service providers, which where most of them were small scale businesses. So that so allowing enough information for Mark to view the details of the services, it allows him to have a much more deeper conversations and thereby enabling a community in the area. So how we approached this problem was that he already had a map view on which he would be viewing these locations. So providing more details on those specific page could be more sustainable and easy to digest. So we have the acceptance criteria as when he uploads an image and when he clicks on the locations, he have enough details of the company so that he could either look them up in the map or he could even use a yellow page to find more details on these institutions.
Hello, it's me again, Akanksha. So I will be going over our test cases. So as you can see, we have created test cases for the two major user stories, which was the recycling location and support map view. So for the recycling location, we have just cases like locate the recycling location and expected results where users should be able to see the recycling location link and it should be clickable. The test result is the recycling location link is visible and the user once the user clicks on the button, it redirects him to the recycling location and the test case is a pass. Then our next test case is locate recycle button. So the expected result is once we choose the image to upload, then there will be a recycling button should be visible and clickable. And once the user click on the recycling button, it should be clickable and it should take us to the results page and the test case is passed. And the next test case is the nearby recycling location list. A user should be able to see a list of recycling location in the screen. The test result is the users are able to see a list of recycling location and the test cases pass. And for the second user story support map view, we can see uh, Google Map is visible. So the expected result is user should be able to see all the recycling location pinned on the Google Map integrated. The test result is once user click on the list of recycling location list, all the recycling companies are pinned to Google Map in the Squander application, and the test cases pass. Details of the pinned location. When the user click on the pinned location in the map showing the recycling company name and details, test results is once user hovers over the pinned location, it shows you the recycling company name, which is location, and the test cases are passed. And the last test case is the distance from your location. User should be able to see the distance from his home to recycling location. And the test result is once user click on any recycling location, it shows the distance between the user location to the recycling location, and the test case is a pass. Then let's go over our stories which are completed. As we can see, we plan to do 4 user stories this sprint, but we were able to complete only 3 major user stories this sprint, which are to view multiple recycling location, to support map view and automatically load locations, and the story which is not yet completed as and it is in progress, which is spilled into our sprint 7, is viewing the details of the recycling location. As a team we faced a major blocker as we were unable to resolve the API issue in this. Finally, we got some breakthrough and we are working onto it, and this will be delivered into our sprint 7. Here is our rundown chart looks like. As you can see, at the start of the sprint we were a little behind our work, but in the middle of our sprint we catched up on our work, and that is followed by the trend. And again in the end of the sprint we did fall behind a little bit, but in the end we did catch up on all our work. And this is how our committed and completed ratio looks like. As you can see, from sprint 1 to sprint 4, we have a committed to completed ratio of 100%. But on sprint 5 and sprint 6, we could see since in sprint 5, the committed versus completed ratio was 89.47, and in sprint 6 this was 97.36. As you can see, as I told you in that we are working on a user story and just a small part of it left. So yeah, and the average team velocity is 97.80.
Hello everyone, my name is Rajat Nagaukar and I will be talking about a retrospective. This time in retrospective we have what went well, what needs improvement and future actions. What went well was improvements from feedback and continuous delivery, and adaptation blockers went well. The improvements needed for this were are estimation on sprint capacity and regular sprint meetings. The future actions we will be taking to improve this, that is revisit capacity estimation and adjust with schedule and find common time. The next, I will talk about future sprint. The future sprint will be sprint 7, and it will have user stories in the range from SQD65 to SQD79. So the first user story, that is SQD65, states that as a homeowner, Mark wants to view details of recycling location so that he can have a conversation with the company with any query and know all the details of working hour. Its priority will be high and it is yet to be done. The next is XQD68, working on UI and UX and add more features on the navigation bar. The next will be XQD72. As a homeowner, Marks want to know about the frequently asked question screen so that he can get answers to some of the commonly asked question, and its priority will be high. Next to it is XQD 74. As a mechanic, Simon wants to create his own account or user profile on Squander so that he can save his personal information like address, phone number, etc. into the app for later use. So basically, it is creating a user profile for the user so that he can manage all his things such as address, phone number uh, for the later use in the app. And the next two is XQD75, that is redesigning the UI UX, which priority is low. And the following two, that is the last one, is XQD79, that is a redesign Scoundrel to be user friendly, that will be designing the app such that it will give a better user experience to the user while using the app. So next is the project demo. So in the project demo, this time we were working on recycling the location screen. Once the user clicks the photo of the atom that is to be recycled, then and he presses the recycle button, and after that he navigates this to this screen, that is recycling location screen. uh, so uh, so first we first have to give permission to access our current location. So once we navigate to this page, the app request for permission to access the user current location. And if the user allows it, then we are navigated to the recycling location screen, where we see a map integrated and showing the user current location and annotations of the nearby location, uh, that annotations of the nearby locations near the current location. And below it we will have a list of recycling locations, naming the name of the recycling company, such as we can see uh, Aloco Recycling, Copper Recycling, AJ Recycling. So these are the recycling locations related to glass recycling. So in total, we have a map integrated showing the current location and the nearby recycling locations, and below we have a list of recycling locations showing the name of the recycling company. So the next is the API used in our application, that we have used two APIs, that is MapKit API and Core Location API. The MapKit API is used for showing the map or integrating map into the app, and plotting the annotations of the nearby locations. And it is a Apple Map. And another API is Core Location API, that gives current location of the user, and also is used for setting the precision value or the region, or region according to the current location. Next, I will walk you through the GitHub link. So this is our GitHub link. So this is a wiki page of our application, that is Squander application, and below it we have a project description describing what our project does and how it helps the user. Below it we have team members uh, uh, and with their photo and their profile, that is a project manager, a cloud engineer, or machine learning engineer, as developer, and a full stack developer. So below that we have project design, showing the screenshots of the application of various screens, and some description about the app. We also included the technology that we will be using in our app, such as machine learning API, Keras API, and TensorFlow as app development kit, and AWS Cloud Formation. So below it we have an architecture showing uh, the app architecture, that MVC architecture, and how how it collaborates with the cloud, and the deployment of the model onto the cloud. So below that we have also the machine learning architecture. Just telling about how that recognizes a particular item into the different categories. So, and below we have application artifacts showing the installation manual, user manual, and technical paper. We have for this CS692, we have uh, four deliverables, and out of that we have deliver presentation for sprint 5 and sprint 6, with their presentation slides and reviewed technical paper. Also we have attached the sprint burn down charts and velocity charts showing the committed and completed ratio. The last one is that we have artifacts such as we have three personas of the user. So we have attached it, and the test cases according to related to our application. So as we move up, we have in the code section, we have our project documents attached, our team photos, our project resources, everything, such as photos and source codes and everything which is inside this folder. I will walk you through the live application demo of our project. So this is our app developed in the Xcode, and on the right we have a device running. So when I run this application, our app launches, and on the right, as you can see, our application is launched, and till now we have seen that our app recognizes an image and shows what that image is, that is if it is a whether a plastic, metal, glass, cardboard, with their corresponding confidence values. But in this print we have integrated map showing the user showing the user locations and nearby recycling locations. So I will get to walk through to this, that once I press this earth image, we have to select an image from the library, such as if I select glass, and choose it, and after processing that image, then I get what that item is, that is a class, and with the confidence value. So till now we were able to get to recognize what that item was with the confidence value. Then after that we have done such as recycling the particular item, showing the uh, locations, nearby locations to the current location. So once I press the recycle button, I'm able to see my current location and the nearby recycling locations. The current location is seen by a blue dot, and the nearby recycling locations are seen by a red annotation. As you can see, the car dealer waste recycling company is there. Once I press that, the annotation pops up, and mm, if you if you resize the map, you can see the various recycling locations nearby to your current location. um, Below that we have the names of the recycling company, such as Covanta, HNC Metals, Evergreen Recycling Solution, Covanta Essex Company. These all are the recycling companies related to the glass recycling. And as and you can see that in the sprint we have um, integrated a map showing the user current location and annotations of the nearby recycling location. Below that we have attached a list view showing the name of the recycling location. So in the next sprint we'll be planning to uh, get the more details about a particular recycling locations, and manage the scheduling of a particular recycling, and giving a notification to the user. And also, as you can see, if we select a different items from this, you will get a different, it recognizes as trash, and if we recycle, it will give a different recycling location, such as related to trash. So you can see that it is a white trash recycling company. Mm. So, uh, so it is giving the recycling locations for various items such as glass, plastic, metal, and cardboard. According that it selects or it recognizes that item. Thank you.